Hello. In this video we are going to describe the first steps to follow when using an Arduino board with Simulink. We will show how the 4 basic Arduino blocks are used by means of 4 little exercises. I have to mention that Simulink support package for Arduino hardware must be installed previously. This package can be easily found in the tab Home, on Adds-on section, and allows the acquisition of analog and digital sensor data from the Arduino board and control other devices with analog and digital outputs or PWM modulation, creating a versatile and low-cost platform. As told before, 4 exercises will be carried out along all the video. This first exercise tries to turn on the integrated LED of the microcontroller. This LED is incorporated in almost all Arduino boards and its enumeration varies with the board in use. In the case of the Arduino Do, this LED is connected to pin 13, that is why the following block diagram has been made. Thanks to this block diagram we can analyze how to turn on a LED by a 0 and a 1 or by a pulse signal. In the following video, we can see how the built-in LED blinks depending on the input we are choosing. This second exercise consists of obtaining a digital signal by means of a button. When the button is pressed, a 1 boolean will be obtained in the scope of Simulink. Therefore, when the button is not activated, what we will obtain will be a 0. To do this, the following block diagram and circuit have been created. As we can see on the video, when the push button is unpressed there is no connection between the 2 legs of the push button, so the pin is connected to ground through the pull-down resistor and we read a low. When the button is pressed, it makes a connection between its 2 legs, connecting the pin to 3,3 volts, so we read a high. In this exercise, we want to turn on a LED by an analog signal. For this, we will use the DAC pin of the Arduino Do. These pins are responsible for converting a digital signal into analog. We want to turn on and off a LED progressively and at different frequencies, that is why the following block diagram has been designed. As we can see on the video, the LED is turned on progressively and depending on the frequency, this change occurs faster or slower. The higher the frequency, the faster the change. Finally, it is desired to obtain an analog signal on the scope of Simulink. For this, a potentiometer has been used and the following block diagram has been designed. As it can be seen on the video, by turning the shaft of the potentiometer, we change the amount of resistance on either side of the wiper which is connected to the center pin of the potentiometer, which gives us a different analog input. When the shaft is turned all the way in one direction, there are 0 volts going to the pin, and we read 0. When the shaft is turned all the way in the other direction, there are 3.3 volts going to the pin and we read 4095. Once understanding these 4 concepts, block diagrams can be created where all of the aforementioned concepts are mixed together, and thus, create a whole control system.